Welcome. Today we're going to talk about trigonometry, basic trig, right triangle trig. Now in right triangle trig, let me fix that. There we go. These are not quite the height I was expecting. All right, so sine, cosine, tangent, cotangent, secant, and cosecant. These are the abbreviations, and this little circle with a line in it is called theta. It's a Greek letter, and it's used to represent an angle. It's a variable used to represent an angle. Other variables that are used to represent an angle are beta, and you could have several others, but typically theta and beta are the two most common. Sine of theta equals the opposite side over the hypotenuse side. That's the tangent ratio for sine. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is hypotenuse over adjacent, and cosecant is hypotenuse over opposite. This is also in your book, but you may want to write these down. Now this is not sin, it's sine. It's just the abbreviation for it. So if we have theta here, if that's our theta angle, and somebody asked me today, how do I know which one's going to be theta? It's whichever one is given to you as theta. It's very unusual for theta to be the 90-degree angle. It's almost always either one of these acute angles. So the side across from the 90 is always the hypotenuse side. That's always your longest side. The side across from theta is the opposite side. And the side that connects the angle with the 90-degree angle is called the adjacent side. Now, each of the sides that make up the 90-degree angle are the legs of a right triangle. You may remember hearing that. And the side across from that is, or the third side, is the hypotenuse. So, if that's the setup, opposites, if theta is there, you'll notice in this case, instead of opposite being down here, we flipped it around, changed which of the angles was theta. This would be your opposite. This would be your adjacent. And so this is the hypotenuse. Now you could use A, O, and H for those sides. It's okay. I just used the three-letter abbreviation. Now if I look at this one, here's my adjacent, my theta. The adjacent side is the side that connects the angle with the 90-degree angle. So this is the adjacent. This is across from the 90, so that's the hypotenuse. And across from theta is the opposite. Hopefully that's clear for you. Let's go on. Given this, find these 6 trig ratios. Well, to be able to do that, first I realized that my theta is there. It's been given to me. And I also notice that I only have 2 of the sides and I'm missing the third. Well, if I've got 2 sides of a right triangle and I need the third, I can use the Pythagorean theorem. Now, it doesn't matter whether this is let me just choose a different color here. doesn't matter if this is A or if this is A. I'm going to choose this to be A and this to be B. You can interchange the legs, but you can't do that for the hypotenuse. The hypotenuse is always C. So 6, okay, that's funky. 6 squared plus 8 squared equals C squared, because remember, A squared plus B squared equals C squared. 36 plus 64 equals C squared, or 100 equals C squared. I square root both sides to solve for C. C is 10. So I'll call that 10. Now that I have that information up here, I can go over and start filling these in. Sine is opposite, by the way, opposite, adjacent, hypotenuse. Opposite over hypotenuse for sine. 6 over 10, we know that's 3/5. And you should reduce them if you can. Cosine is going to be adjacent over hypotenuse, or 4/5. Tangent is going to be opposite over adjacent. 10, nope. Opposite over adjacent, 6 over 8, which is 3/4. Now, if we go back, tangent opposite over adjacent, cotangent adjacent over opposite. So cotangent adjacent over opposite, and that's 4/3. Secant happens to be, let's see, hypotenuse over adjacent, whoops. Hypotenuse is 10 over adjacent 8. So that's 5/4. And finally, cosecant is a hypotenuse over opposite. So that's 5/3. Let me just make an adjustment here. There we go. All right. By the way, you may or may not have noticed, but tangent and cotangent are reciprocals of each other. It would be nice to say that the trig function and its co were reciprocals, but that's not true. Only tangent and cotangent are. The sine is reciprocal with cosecant, and the cosine is reciprocal with secant. So if you can't remember which of these matches with which of these, the regular with the co with the regular. Okay. See if you can do this one on your own, and then after you've unpaused the video, see if you can match what I've done. Hopefully you've done it correctly. Now I'm going to find the third side. This is the hypotenuse. So 2 squared plus, I'll call it b squared, equals 5 squared. Notice that 5 is not b. 5 is c. So we have to make sure it's by itself on the other side. 4 plus b squared equals 25. I subtract 4 from both sides. B squared equals 21. Then I'm going to square root both sides. B equals square root of 21. Let's fill that in, square root 21. And just a reminder for you, if this is theta, this is the hypotenuse, opposite, adjacent. All right. Sine, opposite, over hypotenuse. Cosine, adjacent, over hypotenuse. And tangent is opposite over adjacent. Well, that went pretty smoothly. And if you recall, I've got the color coordinated which one are reciprocals of which one. Tangent and cotangent. So reciprocal to square root of 21. Well, that's great, except I can't leave a square root in my denominator. So I have to multiply top and bottom by square root of 21. And that gets me 2 square root 21 over 21. And that's the proper way to end that answer. In secant, that's just 5 over 2. And cosecant, 5 over square root 21. Well, again, I have an issue. I have to multiply top and bottom by square root of 21 to rationalize that denominator. 5 square root 21 over 21. And there's your final answers. Any questions? Check back and see if you can follow it again. Here we go. Here's our next one. So in these problems, what I'm talking about here are special right triangles. In this case, the 30, 60, 90 triangle. Now, special right triangles like these have particular side ratios. The opposite, the 30, is going to be the 1x side. Now, you might use 1w or 1y because sometimes x is used as your variable. So you may want to be careful of using x. You might want to try w in your notes. In fact, I might even do that for this notes. I'll call it the 1w side. Across from the 90 is the 2w side, and across from the 60 is the w square root of 3 side. All right, so if those are your ratio of sides, by the way, one thing to notice, the smallest angle has the smallest side across from it, middle side and biggest side has the biggest angle. If I start with this side being 15, that's the 2w side. So 1w is half that, or 15 over 2. The remaining side is the w square root of 3, or 15 square root of 3 over 2. We could have said 15 over 2 times square root of 3, same thing. Let's take a look at some other possibilities. What if we're given that this side, which is the 1w side, is 12, then the 2w side would be 24. The w square root of 3 side, remember w is 12, so 12 square root of 3. Over here, we're given that this side, which is the w square root of 3 side, is 4 square root of 3. Well, if 4 square root of 3 is w square root of 3, well, 4 has to be w. So the w side is 4, and 2w would be 8. Now the hardest one of these is when you're given this special situation, where the w square root of 3 side does not have a square root of 3 in it. That makes it a little harder to do. So I need to know what w is. Well, if 8 is equal to w square root of 3, and I want to know what w is, I have to divide both sides by square root of 3. So that gets me w equals 8 over square root of 3. Problem is, I don't want a square root in my denominator, so I'm going to multiply top and bottom by square root of 3. So that's going to be 8 square root of 3 over 3. And that's the value of w, 8 square root of 3 over 3. Now if I want 2w, I have to multiply it by 2 rather. So I get 16 square root of 3 over 3 still. I only multiplied the top by 2, not the bottom by 2. And there's my answers when you're given an integer as your w square root of 3 side, across from the 60. 45, 45, 90 triangles are actually a little easier. 1w, 1w, w square root of 2. So 1 was square root of 3, 30, 60, 90 square root of 3, 45, 45, 90 square root of 2. All right, so if this side is 10, that makes this side 10. And this side is, w is 10, w 10 square root of 2. If this is 15 square root of 2, then 15 is my w, so 15 and 15. That was pretty easy. Here, however, 18 is my w square root of 2 side. So I'm going to divide by square root of 2. Rationalize by multiplying top and bottom by square root of 2. Now, what's neat here is 18 and 2 can reduce. 9 and 1. So 9 square root of 2 over 1 is just 9 square root of 2. 9 square root of 2, that's my w. And there you have the whole thing. Hope that was clear. Let's go on to finding a side given an angle and a side of a right triangle. Well, we're going to use Trig to do this, and here is where your calculator is going to come in handy. If you do not have a scientific calculator, this is going to cause you some trouble. You can do this using the back of the book, page 802. That has a table of trig values, and you can look up a table of trig values online, but you really should have a scientific calculator because we are going to be using it later to do inverse sine and inverse cosine, and without that, that would be much more difficult to do. So please make sure you get that. We've been talking about it since the beginning of the year. So there is our angle. That's our theta. We're asking us to find x. We're given this side, which is the hypotenuse. So we know the hypotenuse and the opposite side from the theta. Which of these trig functions, and we're only allowed to use these because these are on our calculator, so only these trig functions, which of these uses hypotenuse and opposite? Well, it turns out it's sine that uses hypotenuse and opposite. Sine of our theta, which is 35 degrees, equals opposite over hypotenuse. There's my equation. Now, when I use my calculator, first thing, 35 sine. Now, some of you have to type the number first, then sine. Others of you, depending upon the calculator, hit sine, then the number. No matter which way you do it, you need to make sure that your calculator is in degrees, not radians or gradients. So, and we're going to round to 4 decimal places when we find sine, cosine, or tangent. So it's 0.5736. That's how I get my answer for sine, cosine, or tangent, rounded to 4 decimal places. Now, in this particular case, it's easy to solve, but if x were on the bottom instead of the top, you're going to make this a fraction and cross multiply. You can always make it a fraction and cross multiply, but it is easier to solve when x is on the bottom to do it this way. The other way you could do it, in this case, is just multiply both sides by 4. And that way, it will get our answer. X equals, let's see, 0.5736 times 4, 2.2944. Now, when we do this, we're going to ask you to round to 2 decimal places only for your final answer. So 2.29, the 4 does not make the 9 go up. If you have any questions on rounding, please ask me in class. So 2.29, there is your final answer for the value of x. Let's go on to drawing angles greater than 90, even greater than 360, or even negative angles. In all these cases, we're going to start our initial side at the positive x-axis. Positive angles go counterclockwise, and negative angles go clockwise. Now, 480, if I'm drawing an angle, like if I were doing a 45-degree angle, there's my terminal side, that's my ending side. So that's where it ends. And that would be a 45-degree angle. Well, that's great, except that's not what I'm asked to find. I'm asked to find a 480-degree angle. Well, if I subtract 360, so I go all the way around once, that's 360 degrees. 90, 180, 270, up to 360. Now I have to keep going around in that same direction. If I took 360 away, that'd be 120. So that's 30 more than the 90 here. So I have to continue this till I end up, and let me just grab this, approximately here. Now, I'm not expecting you to be perfect with these, but you should be in the right ballpark. You shouldn't have it way down here for 480 degrees, because it's only 30 degrees away from vertical here. And that's how you would draw. Include the spiral in your actual drawing. If I did negative 330 degrees, well, this is 270, that's negative direction. 330, that's 60 more degrees, because it's only 30 less. So that's somewhere in this neighborhood. And come on. It's around there. So I actually didn't draw quite far enough. Right there. That's where I want to be. And there's my terminal side of that angle. Finally, 1,000 degrees. Well, see if you can do this. I think you can. Give it a try. All right, now that you've given that a try, how many 360 degrees or full circles are we going to have in 1,000? Well, if I subtract 360 from 1,000, that would be, let's see, 640. And then if I subtract another 360, that would be, let's see, that's a 5, 0, 8, 2, 280 degrees. Okay, so 2 full times around and then another 280. 270 is 3/4, so 280 is just 10 degrees more than 3/4. All right, so 1, 2, 1, 2, 3/4, and just a little bit more. Approximately there. And that's how you do 1,000 degrees when you're trying to draw it out. Red is or orange is the initial side, and the terminal side is the blue. Okay. Last but not least, coterminal angles. They end in the same place. Now 210 degrees, this is 180, so 30 more degrees. 210 degrees is somewhere around that, roughly. Now, if I were to go around once and then end here, that would be 360 degrees more than what I started with, right? Because that's what I started with, 360 plus that. So if I add 360 to this, that would give me a coterminal angle, so 570 degrees. Now the book is going to look for a positive and a negative coterminal angle. That's what they really want. Well, if I wanted a negative coterminal angle, I'd start here and go this way. Well, if I say 210 minus 360, we know that's going to be negative, right? So 210 minus 360, a negative 150 degrees. So this is a positive one, that is a negative answer. And there's your 2 coterminal angles that they're looking for. Give 700 a try and find 2 coterminal angles for 700 degrees. All right, so the first coterminal angle, you would think, oh, add 360, subtract 360. Well, that's great when the number is between positive, less than positive 360, but bigger than negative 360. When the number is bigger than positive 360, I'm going to actually subtract 360. That's going to give me my first one. 700 minus 360 for 340. There's my first one. So that's one answer. If I say 340 minus 360, that's going to give me negative 20 degrees, and that is my negative answer. So there's a positive coterminal of 340 and a negative coterminal of 20 degrees. And I believe that's our last slide. It is. So please give those problems a try that are in Google Classroom. Have a great day.